Protista Phyla by Jackson Bagley. Ciliophora. Protista in the Ciliophora phylum can be identified by the appearance of cilia, hair-like organelles on the surface of its cells. Within Ciliophora there are two different nuclei, the smaller micronucleus and the larger macronucleus. They either reproduce asexually through fission or reproduce sexually through meiosis. Some examples of Ciliophora species are the Paramecium, Soleps, and the Vorticella. The second phylum is the Sporozoa phylum, which I'll be referring to as the Apicomplexa phylum. Each species from Apicomplexa are all parasites. Apicomplexian organisms have the apical complex on one end of its cell. This diagram shows the organelles that can be found in the apical complex. By using the organelles found in the apical complex, apicomplexan organisms can break through cell walls and invade the host cell. Once inside of a host cell, they duplicate their genetic information and reproduce asexually using mitosis. The offspring of that mitosis may end up being gametes, which will form gametes that undergo meiosis and create a whole new parasitic organism. Examples of these parasites are malaria, one found inside of a dog's intestine, and the common tick. Next up is the Mastigophora phylum. Mastigophora organisms use a flagella for locomotion. Along with flagella, some mastigophorians employ the usage of pseudopodia. Pseudopodia movement is where cells drag their own cytoplasm towards their destination and pull themselves along. Apart from the appearance of flagella, mastigophorians are also unicellular and heterotrophic. They can reproduce asexually through fission or sexually by meiosis. Three species from Mastigophora are Giardia lamblea, Trichomonas vaginalis, and Trypanosoa lewisi. The fourth phylum is Euglenophyta. Each euglenoid is a unicellular underwater algae. Like Mastigophora, euglenoids also use flagella to move around, but unlike Mastigophora organisms, they have two rooted in a canal, and only one is long enough to sprout out and be able to move. Not only is the number of flagella different, but the structure is as well. While on the left you can see the spiral and rod-type structure of a euglenoid flagella, on the right is a much more cleaner and curvier Mastigophora flagella. Three euglenoids are the Phacus longicauda, the Coloecium cyclopicola, and a species from the Trachelomonas genus. The fifth phylum is Sarcodina, and is only made out of amoeba that move using pseudopodia. Unlike in previous phylas, organisms from the Sarcodina phylum aren't confined to any specific shape or size. But like most other protists, amoebas are heterotrophic. Some are even anaerobic and don't require oxygen to live. Amoeba can reproduce asexually through fission, and although they don't have a specific sexual method, can still exchange genetic information with one another. Three amoebas are Amoeba proteus, Caius carnilinus, and Entamoeba histolytica. The last phylum, hint class, we'll be looking at is the Myxomocytes. They were thought to have originally been fungi. This was because they produce spores, but when looked at more closely, their life cycle resembles that of an amoeba more than a fungus. Although slime molds look like a grouping of many cells, it is actually a single multinucleate cell that consumes using phagocytosis. Three slime molds are Physarum polycephalum, Cribaria vulgaris, and Archaea cinerea.